Needless to say, the mathematics of general relativity is extremely complicated. But fortunately, we can simplify at least the idea of general relativity, because as bizarre as it is from our perspective, the idea is fairly simply expressed, and probably nobody expressed it more succinctly than American physicist John Archibald Wheeler when he said, "Matter tells space-time how to curve, space-time tells matter how to move." That's the essence of general relativity summed up in a very pithy statement. What did that mean, and what does that tell us about space-time, and what does that have to do with gravity? Well, according to general relativity, space or mass energy warps space-time, which means if there's no mass energy at all, if we imagined a universe with nothing in it, as was talked about in an earlier video that you just saw, then space-time would be what physicists refer to as flat. There's no warping, there's no curvature. Now, of course, bear in mind that what we've done is we've taken the four-dimensional reality of space-time with its length, width, height, and time. We can't picture four dimensions, and we've simplified it into a two-dimensional analogy. So here we have only length and height, but it will help us to understand the concept. Oftentimes, this is given as an analogy where you imagine the surface of a mattress. If you have the surface of a mattress and there's nothing on it, then it's perfectly flat. But what happens if you add an object to that mattress, or you add mass, some kind of mass, a planet, a star, to space-time? There's our mass. What's it going to do to space-time? Well, the same thing that, say, putting a bowling ball on top of a mattress will do to the mattress. It will cause the surface of the mattress to warp into a hole. And the same thing happens in four-dimensional space-time because of the presence of mass. Now, what a four-dimensional hole looks like is something we can't really picture, but again, we can describe it mathematically and we can understand it from our two-dimensional analogy. So when mass is present in space-time, it sinks into space-time and creates what physicists refer to as a gravitational well. Why a gravitational well? Because in fact, this is our current understanding of why gravity exists. It's a result of, as John Archibald Wheeler said, matter telling space-time how to curve. The curvature of the gravitational well will be a result of the mass and, as we'll see shortly, the size of the matter that is present in it. So how does this explain gravity? Well, according to general relativity then, gravity is not a mysterious pull. It's actually simply the movement of objects rolling along the curves of space-time that are created by other massive objects. And again, to illustrate this, imagine the surface of our bed. And we've placed a bowling ball onto the surface of the bed, and we've created this depression. And now, we take a marble and we put it near the edge of that depression and we let it go. What's going to happen? Well, obviously it's going to roll down the curved surface of the mattress and end up next to the bowling ball. Imagine now that we have the same situation, but now we have a magic bed. And what's magical about this bed is it's invisible. It's still there, it's still shaped exactly the same way, but we can't see it. Well, what's going to happen when we put the marble at the edge of this now invisible depression? Exactly the same thing as happened before. The marble is going to roll down the curved surface of the mattress, only now because the mattress is invisible and we don't know it's there just by looking at it, we might assume that there's actually some mysterious force coming from the bowling ball that is attracting the marble, when really it's nothing of the sort. And this is the idea in general relativity. This is where the second half of Dr. Wheeler's statement comes in. Space-time tells matter how to move. So matter curves space-time, and then other matter moves along those curvatures, and that in fact is our current explanation for why gravity exists.